Practically, so good afternoon to one and all. We have completed the basic introduction about the harmonics, how the harmonics will be added, how the distortion will comes over there. So periodic waveforms, what are the distorted waveform, periodic waveform, how it is going to, what is this distortion is that it indicates. It is the combination of periodic wave and the harmonics. We have already discussed in the previous class. These are the terms. Okay, this one also. This is the blue color. It is a periodic waveforms actually. Sorry, harmonic waveforms. These are the harmonics. That is 1, 2, 3. For half cycle, 3 is that 3 plus 3, that is called 6 half cycles, is nothing but 3 full cycles are there. So third harmonics we are going to call. So this chocolate color waveform, it indicates the periodic waveforms here now. So the combination of periodic waveforms and the harmonic waveforms, that will give the distorted waveforms here now. So it is going to, here it is, because of the harmonics, it is up here now, like this. And because of the periodic waveforms, it is going to consider the highest value and lowest value here. But it will not come back to the zero here, no, or it will not maintain the constant voltage or current here now. Because of the harmonics, the fluctuation will occur over there. So distortion will come over there. So that one we are going to call as distorted waveforms here. So we'll go for the next, that is called harmonic sources. What are the source for the harmonics? How they are going to produce? Okay. So from the commercial load, how their harmonics will be produced in the electrical parameters, voltage, current, the fluctuation will occur over there, how the notches will come, okay, some flickers will come over there. These are all the things we are going to discuss here now. So actually the source for the harmonics are mainly effect of harmonics from the commercial and industrial loads, because in the commercial places only we are going to use the non-linear devices we are going to use, which will give the non-linear output. Those devices we are going to use. Example, the computers, in batteries and all the things. The electronics devices we are going to call that one, where we are going to use maximum electronics devices. That is commercial places we are going to use. Considering one software company, they are going to work on computer only. The computer is completely electronic part, and to provide the backup supply for that computers, we are going to provide the battery supply, UPS and all the things. These all are the electronic converters only here now. So because of this, non-linear output will be produces over there. So far from that one also harmonics will produces. And in industrial loads we are going to consider, suppose weldings are there, arcs we are going to produce over there. Okay, some manufacturing companies. So any paint manufacturing company paint that is which one, that burger paint and all the things, Asian paints and all. The manufacturing companies, they are going to set the timer within that period. It should have to reach to that one. Is nothing but the automatic drives we are going to, the motor speed control, drives control we are going to do that one. So in that places also the drives, whatever the speed control we are going to use, that is, it is create some harmonics over there. So these all the things we are going to consider, those are the sources for the harmonics here. So harmonics of different orders generated when connected power system network by different sources here now, as below here now. Like this, I will tell that one. So the non-linear loads, non-linear load, I told that one, electronic devices, where it is going to use the inverter we are going to consider. Inverter circuit is nothing but electronic devices we are going to use that one. Inverter fed adjustable speed drive here. So you can control the speed drive by adjusting the output and all the things. The example we can consider, so some heaters and all the things in your houses also, that is also adjustable are there. See, in the bakery you have consider any puffs and all the things you consider, they are going to heat particular temperature, they are going to apply that one. That is control, they have controlling that heat control, they are going to do that one. AC you can set the speed and temperature, you can set that one. Okay, so just for our in the offices and all the things, the AC, air conditioning and all the things are there. Especially in your houses, you may 3-4 members in one room you can fix, but in the commercial buildings like companies and all the things, every places they are going to go, the AC duct they are going to provide that one. The heavy air conditioning they are going to use, and through a fan they are going to spread to the all over building like that over there. So this just I'm giving the examples of that one over there. Okay, like a adjustable speed, so which are fed by a inverter supply, those will are the non-linear loads. So because of that one also harmonics may produce over there. So use of power factor corrections. So in the industries and all the things, the matter is for them is the power factor only. The power factor, it is matter. It is not going to maintain exactly. They have to maintain the unity power factor over there. Okay. So for that reason, but it is not satisfied for the corporation companies. They have set it that when you have to maintain this much power factor. Otherwise, you will add the fine for your electricity bill in that one. So to maintain the power factor, what they are going to use to manage the resistive and inductive loads. So they are going to add a capacitors here now. Capacitor, parallel capacitors they are going to use, where the induction load they are going to use on that condition, capacitors they are going to add over there for the, which creates the parallel or series resonance it is going to create over there. So series and parallel resonance sounds, they are going to increase the harmonic distortion, they are going to increase that one. Okay. Just a minute, on two more persons they had it. 60, 16, 5. So the third one is process control and solid state power conversion equipments here. So we can control the process, the manufacturing process, we can control that one in a rice mills and all the things, the solid state, whatever the waste is and all the things. So process of control and solid state power conversion equipments will produce us the harmonics over there. Energy efficient compact CFLs, they are going to use that. Actually fluorescent lamp itself, it is an electronics device, because we are going to use the electronic ballast nowadays. So because of that one also some harmonics will produce us. Okay, so that electronic ballast and all the things we can consider. Static VR, so sorry, for fifth one, use of AC and DC adjustable speed drives here. So you have to adjust the speed of the motors. Because of that one already starting I told that one. So harmonics may produce us over there. Static VR compensator. VR is the unit of reactive power actually here. Okay. Unit of volt ampere reactive, that is reactive power compensation we have to do. See, we by using these capacitors, inductors and all the things, we can control the impedance. Impedance we can control. Impedance is controlled nothing but we can indirectly we can controlling the voltage or current over there. So mainly the inductive and capacitive loads only the reactive power variation will be over, so vary. So because of that one, the main concentration of the power supply we are going to give for the real power, reactive power compensation only. So for that reason only so many devices are there: TCSC, SBC, StatCom, DStatCom, UPFC, IPFC, okay, TCR, TCBR, TCVR, PH, TCPAR, like that. So many devices are there to control or to maintain the, to compensate the reactive power. So the word they have added here now, static VAR compensator. These are nothing but SVC we are going to call that. SVC, static VAR compensators here. Next one, the transformers produce very high levels of harmonics. Initially, after manufacturing the transformers, though while installing, they have to do the testing. After testing, they will install that one. Suddenly, by doing the installation and irrigation of erection of that transformer on that condition, it will produce very large harmonics over there. So high level of harmonics will be produced at the initial condition of the energization of the transformer. So transformers produce very high level of harmonics when they are initially energized. The so-called inrush current will be generate harmonics of several orders over there. So starting at the energization condition, once the transformer is energized, so it will normally it is going to operate. There is no harmonics and all the things. Only for the initial, when we have to energize without connecting the supply, we will take into the and load it, shift to the area designated route or the place after connecting, doing the connection. Once we have given the suddenly the supply we have given, so it will inrush current. Suddenly the current will flow that one. So because of that one, harmonics will be produced. So example, I will give that one. You know, any one syntax you will fill the water. There is no output at all the things. Suddenly you will give the input and output over there without that output. Because of that one, suddenly the water will rush over there. Or if any breaks are occurred over there. Like that, it will flow that one. Once the tank will be half and it will touches to that level, slowly the water will start input to the output equal. We have into manage over there. Like that in the transformer also, at the initial condition while doing the energization, suddenly we have given the current means will inrush, the inrush current will flow. Sudden the current flow of that one, that is inrush current we are going to call. Because of that, the high level of harmonics will be produced here. So other than this, we are going to use the frequency converters, that is called cycloconverters. In a commercial buildings, we are going to use a lift. Elevators, we are going to use tractions, AC voltage regulators, UPS, battery supply, charger, and all the things. They have the electronics devices which are non-linear loads. So because of that, some harmonics will be produced in the electrical power systems over there. So I have not considered here. No, I have not mentioned anything. This is the industrial, this is a commercial here. Commonly, these are the sources for the harmonic here now. Harmonic sources, loads here now. These all the whatever we have 8 points we have discussed. These are the loads. Anywhere we are using lift means that is producing some harmonics over there. It may be commercial or industrial. Almost in industrial and commercial both we are going to use the lift system here. So these 8 points we have discussed. These are, it may be commercial or industrial also here. So one by one we'll start. That is commercial loads are what, industrial loads are what. So we'll discuss about that one. So we'll start the commercial load. Can you tell the places for commercial load where we can call that commercial area or commercial loads, that one, the places? Which places we are going to call as commercial loads? Yes, anyone? Randomly I will ask. Dungamesh. Mahesh Dungre. What are the commercial places? Nikam, are you there? Unmute किया क्या नहीं? Is it audible? Hello? Just a minute. Okay. So anyone, can you reply? Is it audible or not? Yes, okay, now you are telling. Okay, no problem. So the commercial places, we are going to call that one. You have heard the name of residential areas, commercial areas, industrial areas are there. Okay. The bus stop and surrounding areas, those are the commercial complexes. We are going to call that one. Where the persons they are going to work to perform the duties. So official works, we can call that one. Banks and all the things. These are the commercial buildings. Okay, banks, offices, and all the things. Commercial complexes, we are going to consider that one. Okay, so the places that is called companies are there. So any work computer centers are there. So in the manufacturing companies there, we after manufacturing we are going to store any products of that one in one place, that is called storeroom. We are going to call that one. All the products we have to maintain particular heat. For that reason we are going to use the heaters and all the things. We are going to control that speed of that one. And hospitals are the commercial buildings. Okay, internet data centers are the commercial centers or offices, we are going to call that one. These are the commercial load places here now. Where the commercial loads means these are the places that is called office complexes, department stores, hospitals, internet data centers over there. Okay, and even the colleges also, degree engineering colleges, we can call that one as a commercial only, because everyone they are going to use the all the kinds. Example I will consider for the computer science students. Suddenly for each classes one practical they are having. Suddenly they are going to switch on around 100, 200 computers over there, at least more than 100 computers. So they are going to operate that one. And even our computer lab is also commercial placement. So we have UPS supply and computers we are using in the laboratory here. Just a minute. So these all are the commercial buildings we are going to call that one. So one by one we'll discuss here now. So harmonic sources of from the commercial loads here now. From the commercial load, how the harmonics they are going to produce here now. So in the commercial buildings, what we are going to use normally? So we are going to use the tube lights, that is called fluorescent lamps, we are going to call that. Yes or no? Fluorescent lamps. The tube lights, what we are going to call that is fluorescent. Small one that is round rotation, the tube is there, that is called CFL, that is called compact fluorescent light lamps, we are going to call that one. So these एक minute. The commercial buildings and all the things, because we are not going to sit one person and all the things, like offices around 20-30 members they are going to present. We should have to use the brighter lights should be required, and the electricity should be low. And that considering, by considering these all the aspects over there, we are going to use the high efficient lights only we are going to use. So high efficient lights, we have to get the high light and as well as less electricity bill, we want that one. So obviously we are going to flow for the that fluorescent lamp only, tube lights we are going to call here now. But incandescent lamp, you can compare with incandescent lamp, that is the efficiency is low, electricity is power consumption will be more high and all the things. So that is not efficient. For that reason, the high efficient fluorescent lightning with electronic ballast we are going to call. Actually magnetic ballast and electronic ballast, two types are there in the fluorescent lightning over there. So the electronic ballast we are going to call, that is also electronic device, which will produces the harmonics over there. So this is the main source, fluorescent lamp we are going to call that one. Next we are going to use some motors and all by shifting one place the equipments from one place to another place. And commercial buildings, they have the lifts, elevators and all the things. So in a commercial buildings we can store some vegetables and all the things, market is there, in the malls and all the things. So they are going to use the different speed drives they are going to use. So you have to maintain particular heat, means heater we have to use, the speed of that heater should be maintained, the ventilation or air condition we are going to use over there. So those all the things are how commercial loads we are going to call that one here. Adjustable speed drives for the heating, ventilation and air conditioning loads over there. These are the commercial loads which will produces the harmonics. And elevator drives we are going to call, elevators are there from ground floor to first floor, we are going to go like a staircase, but it should have to rotate. Just we have to stand over there and it will take from first floor ground to first, like that. That is elevator drives we are going to call, like example lifts we are going to call that one. Okay, those are the speed control, that is adjustable speed control devices or drives we are going to consider. Sensitive electronic equipment supplied by a single phase switch mode power supplies over there. Sensitive electronic equipments we are going to use, suppose sensors we are going to use, converters we are going to use, okay, the offices and all the things. So those are the commercial loads which are the sources of harmonics over there. So these 4 points, this one we are going to discuss, this one, and these all the things we will discuss one by one. Okay, so these are the commercial loads which are sources of harmonics over there. So now overall the commercial loads are characterized by large number of small harmonic, which is nothing but producing the loads over there. So the number of harmonics are very large. That is, suppose first harmonics around so many loads are there. They are going to produce also more than 100 numbers of n harmonics are there. But the level of the harmonics is very small over there. Very small over there. Let's suppose first harmonic, second, third harmonics, fifth harmonics, like that we are going to call that one. But number of that one, the third harmonics production, so many equipment, suppose 100 equipment they are producing the third harmonics. Like that, large number of small harmonic producing loads here. These commercial loads are there. Its characteristic what it is saying, they will produce large number of harmonics, but the level of harmonics is very small. For that reason, the commercial loads are characterized by a large number of small harmonics producing load here. Now, these loads are called small harmonic level producing loads. We are going to call them. Depending on the diversity of the different load types, these small harmonic currents may add in phase or cancel each other. We can add into the phase, we can increase, or by adding, that is called minus, it is going to create. So plus and minus both we can cancel each other also. So depending on the diversity, we are going to call that. So voltage distortion levels depends on both the circuit impedances and overall harmonic current distortion here. The current will distort over there here now, but the voltage distortion is V equal to IZ cos, V equal to, what is that one? IZ we can call that one. Okay, so I is nothing but current, Z is nothing but impedance over there. So the voltage distortion is completely depends on impedance and current over only. So the current, if the harmonic currents are added into the supply current, so the some harmonic distortion or current distortion we are going to call that one. So for that reason, whatever the voltage distortions are there, that level of voltage distortion, those levels are depends on both the circuit impedances, you know, the circuit impedances and the overall harmonic current distortions here. So that is the voltage distortions are depends, we are going to call that. Here somewhere we have discussed about the single phase power supply here now. So where we have used that non-linear use of process of control energy exchange. So I don't know actually. Okay, leave that one here now. So next we will consider the single phase power supplies. We are going to consider some sensitive elements we are going to use the single phase power supply. So I think so many people you are going to use laptop, computers and all the things you are using. Okay, so here in the commercial buildings, almost to maintain the documentation, to prepare the reports, okay, to socially connecting and officially to do the official works and all the things, everyone nowadays they are using a computer or laptop over there. So for your computer, how you are going to take the supply? That is single phase supply you are going to take from the power supply. Okay, power switchboard we are going to call. Suppose for your laptop, you are taking a single phase supply only. You are taking a single phase supply only, that is AC supply, but the laptop has some electronics components also. So inside that we will do so many conversions and all the things, the frequency variations we are going to do that. But in your computer, I think some starting of the unit or this explanation of the first unit, I have told that one, all the computers now for the variation of voltage, they are not using the transformer. They are using a SMPS. Somewhere I have told that one. Some places I have told that all the transformers are now replaced by SMPS over there. Just a minute. So the single phase power supplies. I was there. All the peoples who are going to use the computers, laptop, and all the things. For the computers, laptops, you are going to use single phase or three phase supply. So single phase supply only we are going to get, and the switchboards we are going to provide the AC supply. Yes. So the laptops, computers, they are going to use the electronics, and we are getting 230 volts. We have to convert that one into some 12 volts, 6 volts, like that. We have to convert that one. So for the conversion, and we are the power frequency actually that is 50 hertz. So the electronics devices, they are going to operate for more frequencies. So we have to get the more frequency conversions. We have to do that one. The voltage conversion also we have to do that one. So for the same frequency, previously we were using the transformers. So to transfer the electrical energy from one circuit to another circuit, that is nothing but step up or step down to vary the voltage. We were using the transformers in the previous days or previous years. Okay, some few years back we were using. Now all those transformers are in the computer. You open that one. Nobody is using now the single phase transformers over there. The simplified, that is power supply units, they are going to simplified mode power supply points, they are going to use that unit, they are going to use that is called SMPS. We are going to use here. Okay, now they all the transformers are replaced here now. Why it is replaced here now? So it is going to convert that one, and with very high frequencies it is going to use that one here. So it will convert and it is going to rectify it again with high frequency AC. They are going to provide over there, and wherever required for the DC, then also it is going to give the DC supply or rectification also it is going to do that one. So for that reason only we are going to call that one switched mode power supply here. Now we are going to switched mode. It is going to switch that one AC, DC, and frequency switching and all the things it is going to do here. So by doing all the computers, they have the SMPS, means this all the computer, wherever the computers we are going to use, the almost we are the majority of the computer usage is there in the commercial places, commercial buildings, offices, wherever the battery storage is there, backup is there, computers is there. So in these places we are going to use. So those are the sources for the harmonics we are going to call that. Okay. Single phase power supplies, electronic power supplies are very important in commercial premises because increased utilization of personal computers. Okay, so it is going to increase the utilization of personal computers. Adjustable speed drives are there, DC motor drives are there, battery chargers are there. So electronic supplies here now. So the SMPS is now replacing the old transformer power supply. Okay, so you can compare with old power transformer. We can compare with that one. Anyone, can you tell me the definition of transformer? Transformer definition. At least what do you mean by transformer? Yes. You are in final year. I will not point out any names. If you know, you tell yes. If you don't know, you don't tell no at least. So what do you mean by transformer? At least single phase transformer definition you tell that.
It is static device which transfer power from one circuit to another circuit.
Which transfers power from one circuit to another circuit. Okay. So this is actually the difference should be there. It will transfer the power from one circuit to another circuit at constant frequency or without changing the frequency. Whatever the input frequency is there, same frequency we are going to get that the output. In some places, that is advantage of the transformer. Okay, that is the advantages wherever the like a transmission system, distribution system, okay, utility side and all the things, that is advantage. But while considering the harmonics and all the things, and for the efficiently in a computers and all the things, it was actually the size of that one, the transformer is not small over there, though because of the size, and it is not efficiently we are going to, so many conversions are there, means the cost will be increases. Okay, so this, by considering this all the things, the SMPS we are going to use. So SMPS we are going to use. What there it is going to do here now, directly whatever the rectifier unit is there, that is directly connect to the supply. So the output of that one we are going to get the DC. That DC is converting into high frequency ACs we are going to convert here. So the direct current that is called the DC supply is, by using SMPS, directly we are converting into the very high frequency AC we are going to convert. Then if again you want that is rectified, that is balanced and all controlled, we can subsequently convert again that one here. Same thing you have written here now. See, the SMPS is now replacing the old transformer power supplies here. We are not connecting any power transformer and all the things here. The input diodes, that is called rectifier circuit, we are going to consider in the rectifier circuit. The input diode is directly connected to the AC main here. So we have to convert AC to DC, we are converting here now. So eliminating transformer here. Yeah, transformer we have eliminated. The input of the circuit is directly, that is diode circuit or rectifier circuit is directly connected to the AC main over there. So this, because of using this rectifier, what it is going to do, that AC is converting into direct current here. It is going to convert the AC to DC, that is called rectifier here. So that DC, what we are going to do again, the direct current is then converted to a AC at very high frequency by the switches and subsequently rectified again by using a switches here now. So we are going to convert that DC into the AC with very high frequency. We can convert that one, and subsequently we can require DC supply, then we are going to rectify it again over there. So like this, the SMPS we are going to use because of this one here. So all the computer peripherals are now employ SMPS because of its lightweight. The weight of the SMPS is very less. Size will be very small, that is compact in size. So operation of that one is efficient operation it is going to give, and lack of need for transformer here. There is, so it is giving the lightweight to computers and all the things. The very size we have to reduce that one. Have to reduce the size. So reducing the size and all the things. So compact size we have to use that one. So the size of the what is that SMPS is very small. Weight is also like you can lift the CPU and all the things easily. You can take from one place to another place for the installation purpose and all the things. Okay, so it will not consume more spaces. Working place, it is going to increase that one. So by considering this one, we can form so many advantages over there. If the size of the SMPS is less, then the computer size is going to reduce that one. So we can place the office working area place, we can increase by reducing the size of the computers, peripherals and all the things. But it has these advantages as compared with the transformers. Okay, comparing with transformer, these many advantages are there. But it also causes some harmonics, it is going to cause that one. It is going to cause the harmonics over there. So that is the disadvantage here. So SMPS causes very high, that is called third harmonics, it is going to cause here. This third harmonics causes the overloading of neutral conductance. Whatever the neutral line is there, phase and neutral, that one it is going to overload, it is going to occur, and especially where the undesired old neutral wires may have been installed here. So that is the third harmonics it is going to produce here now. So that is undersized old neutral wires may have been installed over there. That is, you can install that one here. So it has some advantages, means it has some disadvantages also. We are discussing about the harmonics. Harmonics are not required in the electrical systems actually, which is going to create some problems of voltage fluctuation, distortion will produce us over there, heating will be there, and overloading and all the things it is going to do that one. So we have to reduce. So this is the single phase power supply problems are sources of the harmonics from the commercial loads. Told that one. Yes. Someone has unmuted. Who is that? So we have shown here the conversion, whatever the AC is there, that is for the half rectifier, it is converted into not AC. This is current only we are using here. The current only, the half cycle, not half cycle, the positive, and here the some conversion is there. So because of that, it is off, next again negative, positive, like that. Some distortions occurred over there. See here, you concentrate here now. This is the frequency versus that is current. We are going to call that one. How the frequency we have increased, like that the current will start to decrease here. It's cancelling each other here now. The current, the frequency is increased for the higher frequency. See here, the current is start to decreases here, here also decrease, and for around 1400 hertz, that is called the frequency. Here also some lines, dots are there here. It is for the 2 kilohertz, the current will become 0, or it is going to distort completely. It is 0, it is going to do that one by increasing the frequency. This is how the frequency will vary over there. We can find here now. So this is for single phase power supply. We have considered SMPS and computers we have discussed here. Next we'll go for the fluorescent lamping here. Whatever the in your our colleges also, all the labs, classrooms, the passage area, everywhere we are using a fluorescent lamp. Fluorescent lamping only we are going to use to get the efficient light we are going to get here now. For that reason, we are going to we'll go for the fluorescent lighting. We are going to do that one, because these fluorescent are tube lights. They are 40 to 60% efficient actually. Okay, now the CFL or fluorescent lamps are replacing by LED now. They are replacing by LED now. Never, almost in the residential area we have replaced LED, but the commercial buildings they are not doing that one because the fluorescent lamp it is going to give the efficient lights over there. So by considering previous method or previous some 2-3 years back in the textbook by while writing the textbook they have considered that one. According to that, the commercial buildings loads consume 40 to 60% of generated energy for lighting only. Whatever the generation is there, 100% generation, it is out of 100%, 40 to 60% we are going to give that energy into the commercial buildings. Next 40 to 60% we are going to use that one for the industrial and residential buildings. We are going to use that one. That is again it will come the agriculture, it will come agriculture also we can provide that one here now. So all the things we have to consider. So lighting, that is in the 1995 they have considered that one. 77% fluorescent lighting we were used, and 14% incandescent lamp in a commercial buildings. Still, I will agree that one 70%, 75% commercial buildings we are going to use the fluorescent lamps. We are using fluorescent lamps only. So that is 14% incandescent, that is actually not efficient lamps we are going to cause. That is 10 rupee bulb, we are going to 100-watt bulb and all the things. That is incandescent lamp we are going to call that. We are using. In discharge lamp, ballasts are used for generating high initial voltages. So whatever the in a fluorescent lamp, we are going to use the ballast for generating the high initial voltage across that fluorescent tube over there. So after establishing the electrons flow from one electrode to another electrode over there. So during the tube lights, that is fluorescent lamp, from one electrode to another electrode, inside that fluorescent gas is filled over there. So it will flow from electrons should flow from one electrode to another electrode. For that reason, we have to create very high voltage, initial high voltage is required over there. So establish that high voltages, we are going to use the ballast circuit we are going to use here. Okay, after that one, the electrodes, electrons will flow from one electrode to another electrode. Our current increases and the voltage will decreases. Again, whatever the normal voltage is that is continuously it is going to run that lamps. So discharge is a short circuit. Whatever the discharge we are going to do, that is a short circuit. By doing a short circuit, we are going to use here now. Ballast has to reduce the current within the limit to maintain the specified lumen output here. To maintain the lumen output, that is ballast is also a current limiting device. We are going to consider that one. We have to limit the ballast should have to limit the current or reduce the current within the limit. We have to do that one here. So the fluorescent lamping, actually ballast, we are telling ballast and all the things. There are two types of ballasts are there. One is magnetic ballast, another one is electronic ballast. Previously we were using the magnetic ballast only, that is the tubes have that bigger one. I don't know, first year we were actually, some universities they have kept practical for that one also. So in that one they have were studied about that one, you can check that one. So previous I will give example. Starting में ऐसा ट्यूबलाइट ऑन किया तो थोड़ा ब्लिंक होके बाद में थोड़ा 2-3 मिनट के बाद ऑन हो जाता था. That is called magnetic ballast. We are going to call it that one. So iron core used with capacitor, that one which will produces the heat loss it was producing. But almost later on that magnetic ballasts are replaced by electronics. That will the immediately it is going to switch on, switch off. It has started over there. So the switch mode power supply is used to convert the fundamental frequency voltage into a much higher frequency, that is 25 to 40 hertz higher frequency we have converted. That is called same that is SMPS only we are going to call that. Switch mode power supply, that is electronic ballast we were using to convert the fundamental frequency voltage into a much higher frequency over there. We are using the higher frequency. What are the advantages of higher frequency? You can consider small inductor is enough to limit the arc current. We should have to produce the arc in between the one electrode to another electrode in a fluorescent tap. So that inductor is enough over there. Okay, instead of capacitor in the magnetic ballast, we are going to use the a small inductor in the electronic ballast over there. So high frequency eliminates, that is 100 or 120 hertz flicker associated with iron core magnetic blast. By using a iron core magnetic blast, that is the flickers will become over there associated with that one. So by using a high frequency, it is going to eliminate those flickers. It is going to eliminate. So these two are the advantages of using high frequency. We are going to consider that one. So the magnetic ballast can be used for 2 lamps, but electronic ballast can be used for 4 lamps. See that one. For 2 lamps, we can use the magnetic ballast. 4 lamps, we can use the electronic ballast. So why you have to use the magnetic over there? So everyone, they will go for the electronic ballast only here. No. So comparison, electronic ballast produces double or triple standard magnetic ballast harmonic output here. They are using 4 lamps. They are using means that is double or triple harmonics output. It is going to produce that one here. So efficiently we are going to get, but the harmonics production will also increases over that. So other electronic ballasts have specially designed to minimize harmonics and may actually produce less harmonic distortion than the normal magnetic ballast. And lamp combinations we are going to use. Some other electronic ballasts are there which will design for the minimization of the harmonics. We have designed that one. So actually they will produce the less harmonics over there. So typically the third harmonic distortion, that is called THD, we are going to call that one. Sorry, total harmonic distortion, that is called THD, allowed in electronic ballast is between 10 to 32%. Total harmonic distortion allowed is 10 to 32%. So it should not be greater than 32%. That is called excessive according to the American National Standard Institute. And that is, if it is up to 32%, it is okay. If the total harmonic distortion is more than 32%, that is excessive. We are going to consider according to the ANSI Act, that is called C82.11-1993 in the year of that one. They have mentioned that one. So high frequency lamp ballast, we are in the high frequency lamps here. So in many cases, passive filters. So we'll discuss about this standards. Standards already we have discussed about that one. So filtering devices, it is there. Active filters, passive filters are there. We will discuss in the last. We will discuss that. So in many cases, passive filter or filtering method is used to reduce the input current harmonic distortion to less than 20%. For the less than 20% harmonic, to reduce that one, we are going to use the passive filtering method. We are going to use. So harmonics in commercial buildings are usually distributed along the phases in nearly balanced manner. So in the electrical system, we are going to get the 3-phase supply. Okay, 3-phase supply, we are going to get that one. We have to, all the phases should be as single phase supply we are going to give. I will consider that one. So it should be balanced. So here to here, one phase to one neutral, that one line, one phase to one neutral, another phase to one neutral, and another phase to neutral. We have to use the balanced load. We have to apply that. We have to apply the balanced load. Okay. So for the commercial building, we are going to use along with phases, that is under balanced manner only. We are going to consider that one here. This is, so this, if why we are mannering a balanced condition, so harmonics will also initially are balanced condition, they are going to flow here. Harmonic in commercial buildings are usually distributed along the phases here. They are distributed along the phases, they are going to flow over there. So this is harmonic or fluorescent lighting, we are going to call this one. So see here, the waveform of the current is, some fluctuation is there, here flickers are there, here the flickers are there, here the harmonics is added over there. So based on that, again the current is high. So for the high frequencies, the current will start to decrease. That is called almost zero for the higher frequency. We are going to consider that one. So next one is adjustable speed drives are there. Okay. So in the commercial buildings, we are going to use the lifts, elevators, pumps, fan, AC, and all the things over there. So this part will continue in the next class. We'll finish this one also better. We are going to use the adjustable speed drivers. We are going to use in the elevators or lift. Lift is there, means how it is going to move that one. For the first floor, second floor, and all the things. We are controlling the speed over there. We'll press the button of that one. It should have to stop over there. Up to that speed, it should have to maintain that one. It should, then again it should have to reduce that one. Next again, when you will go for the one floor, again it should have to take the pickup and stop over there. So that is adjustable speeds are there. So electronic speed control methods, we are going to use that one. The elevators, they are going to continuously, they are going to rotate that one. Okay, so from belt system we are going to use that will rotate the floors or whatever the staircases, it is going to rotate that one. Some pumps are there, fans are there. Okay, so these are all the things you can do that one. Automatic speed drives consist of electronic power converters here. They have obviously they have considered the power converters that converts constant AC voltage and frequency into the variable voltage and frequency. The voltage and frequency that is variable, constant to variable, they are going to produce that one. That variable is applied to the speed drives or whatever the motors are there, they are applied here over there. So by varying the voltage and frequency, we can maintain the control the speed of the motor and all the things. So that is called adjustable speed drives, we are going to call that one. Variable voltages and frequency allows the adjustable speed drives to control motor speed to match the application requirements, such as slowing a pump or fan and all the things. Okay, so by controlling the voltage, you can control the motor speed. Like that, already we have the different speed control methods of the motors we have studied. Okay, so ASDs also find many applications in the industrial world. These adjustable speed control drives are not only applied for the commercial buildings, it is also applied for the industrial loads also. We are going to use so many adjust speed drives, we are going to use that. So it completes the adjustable speed drive as well as commercial loads. So in the tomorrow class, we'll continue about the harmonic sources from the industrial loads. Yeah. So industrial loads will continue in the next class. We'll stop here only. Just a minute. Sixteen, 19, 16. Just a minute, I will mark the attendance. So 14, 15, 21. Okay. So we'll stop here only and we'll continue in the next class.